Welding aluminum sheet. Are you always stuck on two things? Distortion past 1 mm per meter after welding, and the OEM rejects the part. An IATF 16949 audit wants welding traceability data you never collected. EV aluminum bodies, battery trays, aluminum heat sinks. Whoever solves these two first wins the order. 3 pits of traditional aluminum welding. First, heat input is hard to control. Thin sheet distorts as you weld, and that assembly stress carries into vehicle life. Second, hand TIG bead appearance rides on operator feel, inconsistent, with batch quality drifting. Third, welding parameters are filled in by hand, so the process traceability IATF and VDA audits demand simply doesn't line up. This line pairs a robot with pulse MIG welding. The key is the pulse. Welding current switches on and off at 50 to 300 Hz. Each pulse delivers one droplet. The seam cools fast between pulses, heat input is sliced and controlled precisely. The aluminum sheet never has time to heat up and distort across a wide area. 3 cores. First, pulse frequency controls heat input. Distortion held under 0.5 mm per meter, a third to a quarter of hand TIG. Second, the interrupted cooling forms the fish scale pattern, and seam tensile strength reaches over 80% of base metal, far above a continuous bead's 60 to 70. Third, current, voltage, speed, wire feed, and gas flow, 5 parameters uploaded to the cloud at 10 Hz, bound to the chassis VIN, IATF traceability fully automatic. Watch the demo. The robot torch travels the aluminum seam at constant speed. The pulsed arc flashes rhythmically. The weld pool stacks droplet by droplet, and cooling leaves a clean fish scale ripple. Note the even ripple spacing, no undercut, no burn through. A consistency hand welding struggles to reproduce batch after batch. By the numbers, hand TIG on 1 to 6 mm aluminum runs 0.4 meters per minute with operator-dependent quality. Pulse MIG runs 2 meters per minute, a full 5 times the throughput, with distortion cut more than half, seam strength over 80% of base metal, and visual consistency up 90%. Throughput, quality, and traceability all in one pass. This solution isn't only for battery trays. EV aluminum bodies, aluminum heat sinks, rail transit aluminum car bodies, any thin aluminum, distortion sensitive, traceability required job reuses it. Thicker parts like tray floors run pulse MIG. Extra thin covers of 0.8 to 2 mm can switch to CMT for the lowest heat input. Pick the process by thickness. Integrate one traceability chain across the line. The core of aluminum sheet welding isn't whether the bead looks good. It's whether you can hold distortion down, build real strength, and leave queryable traceability data all at once. Your aluminum welding line right now. How many millimeters per meter of distortion? Are the welding parameters even being collected?